Hello everyone. So today I'm going to discuss to you what is a vertex, a cut vertex. So by the way, my name is Marjan Imperial. So first, what is a cut vertex? A cut vertex is an undirected connected graph. It's an articulation point or a cut vertex. If removing it and edges through it connects the graph. So we begin by looking at this graph G. So in this graph G, notice that G has two components. This one and 2. But if we were to remove the vertex J, this J, and its edges, and its internet edges, then how many components would J have? Well, let's figure it out. We'll raise the vertex. So technically, the graph we're looking at is not G, but G minus vertex of J. So as you can see, in the original, di ba na si J? Well, this is a G minus vertex of J, wala na si J. So it means that, so how many components are in these graphs, in kaninga graphs? So there are 3 components in this graph, which are the 1, 2, 3. So in the graph of G minus vertex of J, there are 3 components. So by reading the vertex J from the graph G, we get a graph that has more components than G did. Thus, we say that J is a cut vertex. Cut vertex. So that's what a cut vertex is. Is a graph that creates additional components. So mo na siya ang cut vertex. Well, on the other hand, wait. Now let's go back to the original graph of G state. So mo siyang original state. So now we're back to the original graph that has 2 components, 1 and 2. What would happen if we deleted G and its incident edges? Well, let's try. So this graph is wala na si G. Diba sa this original kay naman si G, kani siya si G. So diri nga graph wala na si G. So kani nga graph kawag siya G minus vertex of G. So now technically this graph G that we're looking at is the G minus of vertex G. So how many components are in these graphs? So di ba na siya duha? So there's still only 2 components, 1 and 2. So vertex G is not a cut vertex because by deleting G, we don't create any additional components. The graph G has 2 components and the graph G minus vertex of G has 2 components. So again, it is not a cut vertex. So kani siya nga graph kani dili ni siya cut vertex. Well, let's see one more example of a vertex that it's a cut vertex. What happens if we delete the vertex C? So si C kanina po atong i-delete kanina pod. And its incidence edges will edges. So let's do it. So here, as you can see, wala na CC, di ba? Ba, wala na CC dire. So how we're looking at is the graphs G, kani siya, muna siya nga graph G minus vertex of C. The vertex C, and we consider this graph after deleting C, has 3 components. So na siya 3 components. This 1, 2, 3. So naka-add mo siya additional components. So the C, the vertex C is a cut vertex. 'Di ba? Ang cut vertex man kay means nga create more additional components. So again, if the graph without the vertex has more components than the graph with the vertex, then the vertex is a cut vertex. Another way you can think about cut vertices is the vertex is a cut vertex if by deleting that vertex and its incidence edges, you disconnect the component of that vertex belong to. So in this case, we see have letting C disconnects kani siya. Wala si di ba diri? C disconnects these components. Thus, we've now created more components. So diri nakada-add man siya diri. When we originally had that, and that's what makes C is a cut vertex. So kani si C mo siya cut vertex. So ang cut vertex C matawag mo na siya og articulation points. So articulation points is a vertex removing which increases number of connective components. So that is a cut vertex and its example. Mo na siya usaon pagkuha. So man pagkabalo kung cut vertex ba siya og dili.